Let's look at lesson 1.4. Let's see what we can do today. I can apply the angle addition rule. Also, I can name types of angles. How do I measure an angle? Let's first look at what an angle is. An angle is formed by two rays. So a ray has an endpoint and another point. Okay? Two rays or sides with a common endpoint. So this common endpoint connects the two rays to make an angle. Let's name this angle. And the notation, or how we name this angle, is if there's only one angle to one vertex, to one common endpoint, then we can say it's just angle V. But if there's more than one angle with a common endpoint, we can't do that. So we'll practice more with that later. We can also say angle, and that symbol for the angle is very important because we need to report what shape we're talking about. Angle X, V, W. And I put the V in a different color to show you that the vertex is always going to be in the middle of the name. There's one more name that we can write. So we can write angle, and instead of going XVW, we can say WVX. But remember, the vertex, or the common endpoint, has to be in the middle. I've already said our next definition, vertex. A vertex of an angle is the common endpoint. So the common endpoint is so special that it has its own name. Okay. So the vertex is right there. Example 1. Name all three angles in more than one way. When we look at the figure to the right, we can see we have one angle, we have another small angle, and the two angles combined make a larger angle. So if we look at the small yellow angle, we can call that angle 1. Okay. We can also use the three letters A, B, C, the shape of an angle, then angle A, B, C. And B has to be in the middle because it's a special point. It's the vertex. So order matters kind of when you're naming an angle. The vertex has to be in the middle. But whether you put the sides, how you list the sides doesn't matter. So I can see CBA or angle ABC. That's our first angle. If we look at our orange angle, angle 2, we can then use the letters on that angle, C, B, D. So I'm naming an angle, so I make the shape of an angle, C, BD, or angle. Okay. The last angle we can't name with a number. We can't call this angle 1 and 2, but we do have A and B and D as points on the angle that we can use to name. So I can see angle ABD and angle DBA. Okay. Rule number 8, we have our protractor postulate. So this shape down here is called a protractor. It's a tool used to measure angles. So we put one of the sides of the angle on the bottom, and if I put that angle here going through ray OA, I would start measuring on the inside of the protractor. You can see that the numbers go from 0 to 180. If I measure from the outside of the protractor, I would start at 0 over here on the left and measure to the right going to 180. So the protractor rule says given a line AB, so given line AB, so I'm looking at this any given line, and point O on line AB, that's our vertex, a very special point, and all the rays that can be drawn from O can be put in a 1-to-1 correspondence with real numbers from 180. Okay. So we can measure angles. That's all that rule number 8 is saying. And in our next example, it says find the measure of angle DOC. So this is read the measure of angle DOC. Okay. So if I find, oh, there's D and there's C, and O is an endpoint and vertex, common endpoint, I see that it is not, my angle that I'm measuring is not on my line of AOC. So I'm going to measure on the outside here because it has more, it's more precise in my measuring. Just gonna clean this up real quick. So I'm measuring just angle DOC. And I'm going to measure from the outside because I can be more precise in my measurements. I see that my side of my angle is somewhere between 130 and 140 degrees. And if I look really close, I can count 4 little lines on both sides of my side. So that tells me that this side is measuring at 135 degrees. If I do the same on ray OD, I can see that it's exactly in between 60 and 70, so I can name it at 65 degrees. You want to be precise in your measuring and not take any guesses. If I would have measured from the inside, notice that I didn't have as many measuring tick marks to measure from, so I would have been guessing, and we don't want to guess in geometry. So I want to take 135 minus 65 to find the measure of angle DOC. and I get 30 degrees. So I want to do my final reporting as the measure of angle DOC, just like they have in the problem, is equal to 30 degrees. Done. Our learning target today is I can apply the angle addition rule and I can name types of angles. Here we have types of angles. We see we have 4 different names. We have acute, right, obtuse, and straight. So an acute angle is when the measure of the angle, and notice how we have, almost like we have a imaginary protractor on top of all of these angles. Remember that a protractor measures an angle. So we're saying that we have, let's pretend like we have a side of an angle down here and we're measuring right to left. Notice that 90 degrees is exactly perpendicular, which is important when we get to naming angles. So a right angle at exactly 90 degrees is perpendicular. The sides of the angles are perpendicular, and we can put a symbol in the angle of this little box that lets everybody know that it's a 90-degree angle. So when an angle is exactly 90 degrees, we call that a right angle. When an angle is smaller than 90 degrees, but exists, I mean it's bigger than 0 degrees, we call that an acute angle. So it's smaller or less than 90 degrees, but also greater than 0. When an angle is greater than 90 degrees, so I'm reading this right to left, so x is greater than 90 degrees, but it's also less than 180, we call that an obtuse angle. And we don't use a straight angle very much with just one angle, but when we have 2 angles that make a straight angle, it becomes more useful. But we can say a straight angle is exactly or equal to 180 degrees. Here's another example. So an example in measuring and classifying angles. Classifying is another word for classifying is just naming it. So find the measure, so we want to find a number of each angle. Then name each as acute, right, or obtuse. Okay, so we need to measure an angle and then classify it from these 4 pictures above. So I want the first angle is angle AOD, AOD, with O being the vertex. I see that A is at 180, and I'm going to use the outside numbers because I see the other side of my angle is, if I use the inside part, I'd be guessing, but if I measure from the outside part, I can look and count the tick marks. And over here, 1, 2, 3, 4, 1, 2, 3, 4, I could say that's 15 degrees. So I can take 180 minus 15 degrees, which gives me 165. So the measure of angle AOD is 165 degrees. And 165 degrees is between 90 and 180, so I can call that angle obtuse. An obtuse angle. Okay, great. Let's find the measure of angle DOB. So we're still using the side of an angle at 15 degrees, and DOB So let's find where ray B is exactly at 140. So let's see, I want 140 minus 15 gives me 125. So the measure of angle DOB is 125 degrees. And 125 is greater than 90. So I'm looking again at an obtuse angle. Okay. When we have two angles that have the same measure, we call those congruent angles. And so I'm going to do my best to draw angles that look like the same measure as best I can. And remember, congruent is an equal sign with a squiggle on top. I'm going to give these angles points, and points have names with capital letters. So maybe I call this angle CAT and angle DOG. So our notation, we would say angle, always I need to have that picture, that notation there. CAT is congruent to angle DOG. There's one more way that you can see congruent angles, and that is when they're touching or they share one side. So if I draw one really large angle, and as best I can draw it, I draw an array in the center. We call that an angle bisector. Is a ray that divides an angle into two congruent parts. Let's see, let's give these some names. I'll do V for vertex, M, N, and P. Let's practice naming them. So I would say angle MVN is congruent to NVP. Great. Let's look at some examples. But first, our last rule. Rule number 9, our angle addition rule. So if point P is in the interior of angle AOC, let me draw in angle AOC. I know that O is going to be my vertex because it's in the middle of the name. So if point B is in the interior or the inside of angle AOC, right? And what happens is we can say that the left angle plus, what we can say is that the left angle plus the right angle equals the big angle. That's all we're saying here. So I can say the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. So all these words are just saying if you see a picture like this, then you can do part plus part equals whole. There's one more way you could see this picture. So if you see a straight angle, let's call this, we can see AOC, and I don't know where B is. So B is on the inside, so we can connect a ray from O to B. Well, then it's the same thing. We have the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. But what's different about this picture is in the straight angle. Measure of angle AOC plus the measure of angle BOC equals, now I know that AOC is a straight angle, and a straight angle is equal to 180 degrees. Knowing that measure and putting it in my equation will save me a lot of time later on. It really is very helpful to make that substitution. Okay, 2 more examples and then we're good. So example number 3, using the angle addition rule. So here I see the measure of angle ABD is 37 degrees. Well, that's an acute angle. I'm just going to sketch that in. So AB has to be the vertex, D, and I know that that's 37 degrees. And the measure of angle ABC, now I already have A and B drawn. So these two angles are going to share a side. And C, so A and B is already there. That's great. I'm just going to add a side C, and that's 84 degrees. I need to find the measure of DBC. DBC. So I need to find the measure of the big angle. Okay, so if I take 84 plus 37, that's going to give me the measure of angle DBC. And 84 plus 37 is going to give me 121 degrees for the measure of angle DBC. Right? If we look at our last example, we see we've got some algebra plus some vocabulary. Here we see angle bisectors. Remember that bisect means to cut into half, cut into 2 equal parts. Divide into 2 equal parts. So we know that ray BD bisects angle ABC. So let's draw that. So I'm going to draw a really big angle, and that's angle ABC. And ray BD bisects, that means cuts into 2 equal parts. So as best I can, I'm going to draw it in the middle. and name it, label it DB. Because it bisects, I'm going to show that they are the same measure by putting similar arcs in each angle. They give us some information, so measure of angle ABD is 6x plus 3 degrees, and the measure of angle DBC is 8x minus 7 degrees, and we need to find the measure of ABD. Okay, well, since I know that these angles are of the same measure, I can just set them equal to each other. So I can just say 6x plus 3 is equal to 8x minus 7, and solve for x. First thing I'm going to do is I'm going to find my smallest variable, and I'm going to subtract from both sides. Leaves me with 3 is equal to 8x minus 6x, leaves me 2x, and I'm going to bring the negative 7 down. Next, I'm going to move my constants. So the opposite of negative 7 is positive 7. Add to 0, and so I get 3 plus 7 is 10 equals 2x. And to get x all by itself, I'm going to divide by not x. I was talking while I was writing. Lift off. Divide by 2. So 2 over 2 cancels to 1, gives me x equals 5. Great. Let's see if I'm done. If I just need to solve for x, I'm done. But I need to solve for the measure of angle ABD. And we know that the measure of angle of ABD is 6 times the quantity of x plus 3. And we know that x is 5. So let's do the math. 6 times 5 is 30. Plus 3 gives us 33. So the measure of angle ABD is 33 degrees. Great. Now you try.